So let's start DevOps and AWS demo. So before I start the demo, I wish to introduce myself. So my name is Prasad Reddy. I have 18 years of experience working as an architect. Okay, I've been teaching from past 9 years. So I teach DevOps, AWS, .NET, all that. Okay, now this demo is all about DevOps and AWS. So before I get into the demo, I want you to introduce yourself.
Yeah, currently I'm working in series-Devops, control and automation tool. Plus in DevOps also.
DevOps as good.
Yeah, DevOps tools are using Git, TeamCity, UCD. UCD means urban code deployment. It is a database deployment I'm using. More knowledge is required in DevOps, setting Kubernetes transformation purpose. Getting the my skills. That's why I'm
Sure. Thank you. Thank you. Good to know. Yeah. How about others?
Hi, this is Lokesh.
Yeah, Lakesh.
I have 3.5 years of experience as a Linux admin at Virtuosum.
Good, good. Okay. Yeah.
Aishwarya.
Yeah.
Sir, I am Aishwarya. I am new to AWS and DevOps. I
Okay.
worked previously with CTS in Salesforce.
Oh, okay. Good. Okay. Yeah, Rakesh.
Hi, sir. As you know my name, I just completed my bachelor's
Yeah.
in computer science.
Yeah.
I just joined DevOps, sir. I got advised that it's good. It's a good domain to choose.
Okay, sure. Thank you. Yeah. Good to know your introduction so that it is easy for me to connect with you. Okay. Yeah. So let me just open one PPT. Okay, fine. So let's start the demo. Whenever you are planning to learn any technology, any process, any language, very important to understand why is it required. So why DevOps is the question. So let's try to understand that. So in that process, yes, most of you would be knowing it, but yeah, so it is my duty to teach. Okay, so that's the reason. So let's try to understand why DevOps. In the process, you will also get to know what are the tools and the services which you would be learning as part of this particular course. Yeah. When you work for organization, yes, most of you are working for an organization. Okay, so when you work for an organization, you work for a project. So where do you get these projects from? From some client, right? So clients also, most of the cases will be some other organizations. Clients directly doesn't allocate or assign a project to one organization. Client would be verifying n number of organizations, and based on some considerations, they'll be assigning or allocating a project to one particular organization. Now, my point is on what basis they do it. So I would say these are all the 4 factors. One is everyone will look for cost effective. Whoever is little cheaper, they'll incline towards that. At the same time, fastest delivery as well. So since the cost is cheaper, it doesn't mean that you can deliver at your own time, right? So it has to be faster. And at the same time, they look for quality as well. Then high availability. What do you mean by high availability? Always your application should be up and running and you should get quick response. This is high availability. Every organization wish to achieve this for but for some reason it is not happening for all. So what exactly we do is we will divide an organization into two teams. One is development team and the second one is operational team. Development team and operational team. Who comes under development team? Developers, testers, project managers, whoever is responsible for delivering the project, they come under development team. Who comes under operational teams? These guys are admins. Okay, they own environments like test, UAT and production environments. I'll come to that, what is an environment, all that. So my point here is day-to-day life, these guys would be facing some problems. If you can able to identify the problems faced by these two teams and provide solutions to those problems, then we could achieve these four. Okay, now let's try to identify the problem faced by these two teams. So before that, there are few technical terms I will be keep using in this particular demo. So let's try to understand that, then we'll come back to this problem statements. Development and deployment. Development meaning you have some requirements. For that requirements, you write some code and make it work in the developer system is called development. Deployment meaning, yes, it is running successfully in the developer system, but I wish to run it on some other system or set of servers or a single server. So, but how do you run it? Just copying the project file from this system to that system is not sufficient. You need to configure that system. Configure meaning you may need to install some softwares, update some softwares. Okay, then you may need to provide some permissions. Then copying the project files from this system to that system or set of systems or servers is actually called, and making work in that system is actually called deployment. Running the application in developer system is called development. Running the application in some other system or a set of systems is actually called deployment. Fine. Now, environment. In an environment, you will have one or multiple servers. One or multiple servers. Fine. Now, but group of people will be using that particular servers, or I would say set of people. So when I say development environment, developers will be testing the application in the development environment. Then the test environment, testers would be testing the application in test environment. Then UAT environment, client would be validating the application in the UAT environment. Production, actual users will be using in the production environments. Okay, fine. Now let us come back to the problem statement. So when I say developers, development team, definitely developers will be working under that particular team. So what is the job of the developers? They actually write some code. Fine. Now, where do you store that code? If you are storing the code, initially what do? You store it in the developer system. If you are keeping the code only in the developer system, then you will have two problems. One problem is if that particular system get crashed, you will be losing the code. And the second problem is manually you need to keep the code, meaning if you are keeping it somewhere in the server, okay, so you need to manually keep the code. But let's try to tackle the first one. If you are keeping only in the developer system, if that system get crashed, then you will be losing the code. So that's the reason what do? We'll keep it in a server in a common place so that anyone can access it. But here the problem would be manually you need to push the code. When you do something manually, you make mistakes. That's the reason we need to use a tool called version control system. Here we are trying to use or learn Git as a version control system. Git as a version control system. Okay, so definitely about the Git, like what exactly the advantages, why we should be using it in classes, we'll be learning in more detail. Fine. Now I'm using Git as a version control system and I am keeping my project code in the server with the help of Git. Now, deploying the application into the dev environment is the responsibility of the developer. So I'm talking about if the DevOps doesn't exist. Okay, now deploying the application into the dev environment is the responsibility of the developers. So what do? They will be deploying the application once in a day. So why once in a day? Because their core job is to develop, not to deploy. Fine. So that's the reason. Let's say in the evening before they leave office around 5:30 or 6 p.m., they will be trying to deploy the application and leave office. Now, at that time, if they encounter any issue, everyone in the team should sit and fix that particular issue. Why everyone in the team? The reason is this code is actually everyone's code. It's a project code. It's not only one developer code. So that's the reason everyone in the team should sit and fix that particular issue, and they are supposed to fix that particular issue on the same day. They shouldn't come on the next day and try to fix that particular issue. Why same day? Why not next day? The reason is we work on agile methodology. We work on agile methodology. Now, let's talk about what is agile methodology, then we'll come back to this. As soon as you get the requirement from the client, you don't directly start coding it. You need to follow some process. That process is actually called software development lifecycle, SDLC, we call it as. Fine. Now, in this SDLC, we'll have phases called requirement gathering, analysis, design, development, then the testing, then maintenance. Fine. Now, each phase is self-explanatory, but let me explain it. In the requirement gathering, you gather the requirements from the client. Then in the analysis phase, you analyze the requirements. Then in the design phase, you actually design. It's not web design. It is the architecture of the project. Okay, what are the tools we should be using it and how the data should flow, all that. Then you go to the design, you go to the development after design, then to the testing, then to the maintenance. Now, these phases can be implemented by using multiple methodologies, and two of the popular methodologies are waterfall model and agile methodology. Let's talk about first what is waterfall model. There are some disadvantages or limitations in this particular methodologies. That's the reason we use agile methodology. Now, what exactly waterfall model says is you execute SDLC phases one after another. Meaning you completely finish one phase of the SDLC, then only you move to the next phase of the SDLC. Now, one phase fall into the next phase, that's why we call it as waterfall model. Now, according to this, you gather all the requirements, then you analyze all the requirements, then you design for all requirements, then you develop for all requirements, then the testing, then maintenance, like that. Now, let's say you are working on one project and that particular project duration is 12 months and there are 100 requirements. Now, when do you complete the testing phase? 12 months duration. So testing comes before maintenance. After development, you'll get it. Now, most of the cases, like after 10th month or early 11th month, you will be completing the testing phase. Now, after that, you go to the client and ask for a feedback. Till that time, you will not be in a position to take a feedback from the client. At that time, you go to the client and ask for a feedback. Now, at that time, client says, this is not what I have expected. I need these changes. If those changes are small, not a problem, you could accommodate it. If those changes are big, then you will not be in a position to accommodate those changes. The reason is you don't have time. That is the first issue. And the second issue is you might have spent all the money, whatever you got it from the client. So that is a problem. Okay. So sometimes clients think that whatever they are expecting changes are small, but we are making it as big. So let me give you one small example, not related to software, so that you could easily understand that. So what is that example is, let's say there is one car manufacturing unit and they have manufactured around 10,000 cars and they are intended to be sold it in Indian market. Now, because of some reason, some legal issue or something, now they have decided they can't sell it in India. They wish to sell it on UAE market. Now, there is a problem. What is that problem? In India, the steering comes on right hand side. On UAE, it is on left hand side. Now, the architect is thinking, how do I handle? Okay. Now, it is a big problem. How do I handle very quickly? But someone from the sales department are suggesting, saying that why can't you simply pull it from here and fix it there? Is that so easy? It is not so easy. The reason is, accordingly, the other parts of the vehicle are aligned. Correct? Since it exists on the right hand side, the engine and other accessories and everything are aligned in that manner. Yeah. So now if you are replacing it, definitely even other parts of the vehicle, you need to change it, rearrange it. Correct? So the same problem happens in the software projects as well. Okay. So they think it is small, but we know whether it is small or big. Because of that particular change, you may need to change the entire architecture also sometimes. So that becomes a problem. Okay. So that's the reason most of the cases waterfall model is going to be failed. Only 30% is the success rate in the waterfall model. Now, what is the solution for this? Agile method, yeah, is the solution. So, how? In Agile, what exactly happens is instead of taking all requirements, you take few at a time. For example, out of 100, you take 10, 15, 5 or whatever, and you try to execute in short duration. Okay, you take few and execute in short duration. So that short duration can be 2 weeks, 3 weeks or 4 weeks. 2 weeks, 3 weeks or 4 weeks. Yeah, most of the cases 2 weeks. I do agree. Yeah. So this duration we call it as sprint. Correct, right? Now within this duration, you need to complete or you should get a workable product at the end of that particular duration. So why we should get a workable product? The reason is we should take a feedback from the client after that particular end of 2 weeks or 3 weeks or 4 weeks. Now, if the client is actually expecting some changes, definitely you can accommodate those changes. The reason is you are not taking a feedback at the end of the project. You are trying to take a feedback very often, like every 2 weeks, 3 weeks or 4 weeks, you are trying to take a feedback. So that's the reason you will be in a comfortable position to accommodate those changes. Okay. So that's the reason Agile methodology works. So let's say now out of 100, you have taken 10 requirements and 8 are accepted by the client, 2 are not accepted. Total 100, you took 10 out of it, then 90 are there, 2 are not accepted again, then it becomes 92. That we call it as backlog. Out of that 92, you take 12, 15, whatever for the next sprint. Okay, so that is how the cycle works. At the end of all the sprints, everything should be done. Okay, now it's like writing your semester exams instead of directly writing the final exams, right? Okay, so whatever the topics you write it in first semester will not be repeated in the next semester, but here it might get repeated if they are not accepting it. Okay, so that's how Agile methodology works. So since you are taking the feedback very often, most of the you will be in a comfortable position and there is a more success rate in this way of methodology. Okay, that's the reason many of the projects are actually going on Agile. Okay, now let's come back to the issue faced by development team members. Now they are trying to take a build in the evening before they leave office 5:30 or 6 o'clock, right? So then what is the relationship between Agile and this one? Okay, why they should wait? Okay, and they should fix it on the same day. So I was mentioning an Agile sprint, 2, 3 or 4 weeks. Most of the cases we work on 2 week sprint. The reason is 3 or 4 weeks are almost a month. We should not be waiting that much time to take a feedback from the client. So that's the reason I never worked on 3 or 4 week sprint. I always worked on 2 week sprint only. Okay. Yes, most of you would also be. Yes. So now when you say 2 weeks, it's 14 days, right?
Yes.
So in that 14 days, weekends we don't work.
10 days.
Then it becomes 10 days. Then 1 day is required to take a feedback from the client. Then it becomes 9 days. So 1 day is required for integration test, like combine everything into one and do it. So then it becomes 8 days. Half a day is required for planning the sprint. Like what are the requirements we should be taking for that particular sprint? Then it becomes 7.5 days. Within this 7.5 days, we'll have to complete the requirements which you have taken that for that particular sprint. So it is very, very less time, right? Okay. So 7.5 days only. So that is the reason when the developers are trying. Okay, I'm getting an echo. So looks like Rajesh, you have. Can you please mute yourself? Looks like you have joined in 2 devices.
Yes, sir.
Yeah. Okay. So when the developers are trying to take a build in the evening, if they encounter any issue, they are supposed to fix it on the same day. They come on the next day and try to fix the issue. Generally, what will happen? Every day morning, everyone should take the latest code and work on it. Now, there is a problem in that particular code, correct? So in the morning, again, you need to fix it. Then again, we are wasting the time over there. So instead, you stay back, fix it, because we are working on Agile methodology. We are not supposed to waste the time because we have only 7.5 days. So now let's say they were there in the office till 9:30 p.m. or 10 o'clock. Then the very next day, they'll come late to office. If not like 2 hours, 3 hours, at least half an hour, 1 hour. So if there are 6 developers, if each developer is coming 1 hour late, what will happen? We are losing 6 hours over there. Okay, so it is 80% of one man day effort. 8 hours per day will work. In some organizations, 9 hours. Okay, now 80% of time, like one man day effort, we are losing it. If this is happening one day, we can adjust. But if it is keeps happening, correct, then we will not. Yeah, delivery will be a problem. Forget about fastest delivery, not even delivery. Am I correct? Okay, so that is a problem faced by development team members. Development team members. Okay, now that's only a problem statement. We'll come back to the solution. Fine. Now let's talk about operational team members issue. I said they are admins. They own environments like test UAT and production environments. So their responsibility is to deploy the application into those environments. Now, even though they are responsible to deploy the application into those environments, there are some configurations only developer would be doing it related to those environments also, like connection string and all that. So that's the reason they both sit together and they'll be writing instructions saying like this is how it should get deployed into those environments. Using that instructions, operational team members would be trying to deploy the application. While deploying, if they encounter any issue, then operational team member tries to approach development team member for the help. Now development team member says, I am into Agile, I am working on my own task. Okay, whenever you complete my task, I'll assist you. If that whenever comes quickly, not an issue. Otherwise, again, we are not delivering on time. Client would be watching, okay, so it is not getting deployed and it's no one's fault, actually speaking. Both are not wasting the time, but still it is happening, correct? So again, we are not delivering on time, so we get escalation. Now, these are all the issues faced by development team members and operational team members. So that's the reason projects are getting delayed. Now, we need to find a solution for this. What is a solution is, if the development team members and the operational team members communicate and collaborate with the help of automation tools, then we get a solution. The communication and collaboration between the development team members and operational team members with the help of automation is actually called DevOps. You might have seen that logo, right? DevOps. Okay. So theoretically it's fine, but practically, how do you resolve this? I am talking about automation, correct? So let's try to resolve the first issue. What is the first issue? Developers are trying to take a build in the evening before they leave office. Don't do that. Each time developer push the code, you try to take a build. Now, let's say there are 6 developers and I am one among them. I am pushing the till 11 a.m. everything is working fine. Now I pushed at 11 a.m. and if any one of the developer tries to take a build at that time, as soon as I pushed, then if there is any issue in the build, if that particular developer informs to all the team members saying like there is an issue in the build, then everyone knows at the time who has pushed it. I pushed it, then I am the responsible person to fix that particular issue. Others can focus on their own work. That is a solution, but there is a still problem in that solution. What is that problem? If there are 6 developers, each person, let's say, pushing 3 times a day, then it becomes 18 times. All 18 times, if one developer is trying to take a build, okay, then that person will be working on only on deployment activities, not on the development activities. Then either to develop or deploy, you need to hire one more person. If you are hiring one more person, automatically the cost would be increased. So we are not supposed to do that. So that's the reason what we need to do. We should automate that. So how do you automate that? So to automate it, we need to use a tool called Jenkins. I'm not saying this is the only tool we have. Okay, there are n number of tools. You also mentioned few tools, right? Yeah. So there are n number of tools. So this is an open source tool and widely used tool. So that is the reason I am teaching this particular tool. Okay, fine. Now, in this Jenkins, what exactly we do. This is used for CI and CD. I'll come to that. So we create jobs by using this tool. Jobs usually triggers by itself. You don't need to initiate it. It will be keep on verifying whether someone has pushed the code or not. If someone has pushed the code, this job gets triggered. Now, in this job, you need to configure in this particular way. Fine. Now, always remember, I just want to explain one more point here. Deployment, when you say deployment, it is combination of build and release. Build and release. Okay. In the build, what exactly we do? We compile the code, then we unit test. I'll come to that. What is unit test? Everything I explained. But if there are any like automated test cases, we can have it. And the next one would be code review process. Okay. Then at the end of that particular process, you actually take archive files. You create archive files like zip files, jar files, all that. Okay. So that includes the build process. Okay. You don't deploy it. Correct, right? So till you generate archive files, compile unit testing, SonarQube, then this one, till you create archive files that we call it as build process. Then the release process, meaning there is something like CD, continuous deployment and delivery. I'll come to that. Okay. Now in this release process, you actually deploy to the related servers. Okay. That is release process. Fine. Now I am talking about build process. Fine. Now in this process, what exactly you do? You create a job. In that job, first you configure the URL, the Git URL from where you need to pull the code. Okay. So you configure that. Now you get the code into the Jenkins server wherever Jenkins is running. Okay. Then you compile the code. So how do you do that? So you need to use the related build management tools. For example, if you are using Java as a application, so you are trying to deploy Java application. So in that case, what you need to do, you need to use the Java build management tools and or Maven or Gradle. Fine. So using this particular tools, first you compile the code. What do you mean by compilation? Converting your source code into mission understandable language. That's a compilation. So you should do that. Fine. So that you should configure. After that compilation, what you need to do is you can do the unit testing. Unit testing. What do you mean by unit testing? It's actually a function test, not the functionality test, not the future test. Okay. So testers will not be doing this unit testing. Who does this? Developers actually. So I'm saying function test. In a project, you'll be writing n number of functions in the project code. For example, there is a function called add a comma b. I'm just making it as simple. Generally, it will be complex functions. Okay, so add a comma b. What exactly it does? It add two numbers and it will give you the return value. Now, to test that particular function, we write some other function, and there I'll be calling like add 2 comma 3, and I'll expect 5 as a return value. If I get 5, it is working as expected. Why I should be doing is for the regression actually. Okay, regression meaning, let's say in the project you are making some changes in this particular function, and that function is used in multiple places. Functions we actually created to reuse it. Okay, now that function can be used in multiple places in that entire project. If any issue comes on one place, you'll be testing only in that particular place. It might affect other places also. Okay, so in hurry, you will not be testing in all the pages. So you test only that particular page. So that's the reason if you write unit test cases for all possible scenarios, you don't get any issue. Okay, so that's the reason we go for unit testing. Fine. So once the unit testing is done, so you can go for automation test also. That generally comes on release also. So I'm just explaining now. Automation meaning people write by using Selenium and okay, Selenium and so automated test cases. So that can be configured. And after that, there is something like a tool called SonarQube. SonarQube. So why do you need this is, so when you are working for a project, there will be different levels of experienced developers. Correct? One will have two, other will have 10, other will have 8, something like that, right? So you cannot expect everyone to write performance-oriented code or same kind of code. So that's the reason there will be someone like tech lead or architect will be reviewing the code. Reviewing the code line by line is difficulty for anyone because we are into agile methodology. We have only 7.5 days. They can have a glance of it definitely, but not like every line. So that's the reason what you can do is you can use this particular tool and you could review the code. How? There are some rules in the SonarQube for each language. For Java, there will be around 600 rules. For C#, there will be around 450 rules like that. Python, JavaScript, for each and every language. There will be some rules. Using that rules, you review the code. Okay, this tool does it for you. Then, if there are any issues, that deviations will be captured in the SonarQube and developers can log into the SonarQube and then they can verify those deviations. Okay, that is why we use SonarQube. And after that, you generate the archive files. In case of Java, you actually generate jar file, var file, or EAR file. If it is .NET, you might have like DLLs and zip files and all. So it depends on the technology, you get archive files. Archive files meaning in the end, okay, let's say I have 100 Java files. Now after compilation, I'll get like 100 bytecode files. Now I wish to share it with someone else or run as a one file. So how do I do it? So you need to generate as a one file. So to do that, we actually use archive files. Okay, till this, whatever you do it, this we call it as continuous integration. When exactly this is happening? Each time developer push the code. Each time developer push the code, automatically this job is getting triggered and it is getting compiled, unit testing and SonarQube is verifying and you are generating the archive file. Correct? So now this week, that's the reason this process we actually call it as CI. Why CI? Continuous integration. Continuous integration, meaning at any given point of time, your code is deployable code because you have done everything. Okay, now it is deployable code. Fine. So now in this process, if anything goes wrong, you automatically send a notification to the developer team members. Okay, so that they'll understand what is the issue and they can fix that issue and they can push it again. This gets triggered. Okay, notification can be email, Slack, whatever. Okay, fine. Now this is about CI. Using this, the first issue is resolved. Now developers are not taking a build like in the evening 5:30 or 6 o'clock. Now they can focus on development activities, not on the deployment activities because it is automated. Okay, now let's focus on the second issue, which is the issue faced by operational team members. Now, as I mentioned, they're responsible for deploying the application into UAT, test, and production environments. Now, even for that, you create one more job. It's not like only one job you can have it. So you can have multiple jobs, doesn't matter. So create one more job. Create one more job. So let's say if it is a web application, then in that particular server or multiple servers, there will be something like Tomcat. Okay, so this is an application server. To deploy Java web applications, we need Tomcat. Fine. So you create one more job and you deploy these var files into the Tomcat with the help of one more job. This we call it as CD, continuous delivery or deployment. What is the difference? CD deployment meaning continuous deployment meaning as soon as developer push the code, you directly deploy. You do all this and you directly deploy. But delivery meaning there will be a manual interaction. You don't directly deploy it. Okay, someone needs to approve. Then only it gets deployed. So that is delivery. Okay, so now if any issue comes, you are automating that process. If any issue comes in the first run, you'll get to know later on anyway. If you'll be fixing, then there won't be any issues. Okay, in that way, even the second issue also is resolved. Okay, so now in this process, we actually learn first Git, then Linux and shell scripting, Why do we need to learn Linux commands and shell scripting? The reason is 80% of the servers are Linux servers. That's the reason. To maintain that, we need to learn Linux and shell script. Okay, fine. Then after Git and Linux and shell scripting, you'll also learn Java and Node.js. Do not worry, it is not coding part. It is build and release part of those. Okay, fine. Now, then you learn Maven. So Ant is a old technology. You learn Maven, then the SonarQube, Tomcat, Jenkins. Okay, fine. There are other tools also. I'll definitely come to that. So before that, any questions, anyone? Yeah, application server to deploy your dynamic web applications. Web applications. Web services and web applications. Okay, there are it depends on the technology which you are choosing. So in Java, we have something like servlets and all. For that, you don't need to deploy in the Tomcat. You can run it directly. But if it is a WAR file, if it is a web application, then you deploy it. So it depends on the application or a service which you are using it. Okay. And if you are, let's say if you are using Node.js and all, you don't need Tomcat. You don't need Tomcat, Node.js. So that itself is a server, cell phone server. It just spins like that only. You just need to specify one port. Okay, if you are using .NET and all, in Windows, you should be using IAS. Okay, so in Linux, it's a different way. Kestrel and all will be using it. So it depends on the technology, the related servers we should be using. Yeah, yeah. Someone, I think someone else was asking something. Anyone online?
Yes, sir.
Yeah, go ahead, Ashwarya.
No, sir. I have
No.
no doubt.
Okay, fine. Okay, now there are other tools in DevOps also which I will be teaching. I'll cover after like few minutes. Okay, so I'll first now focus on cloud platform. Cloud platform. Okay, which is very important. So that's the reason. What is a cloud platform is the question. Why should I use cloud platform? Okay, before we get into directly the details. So let's try to understand with an example. Let's say you know deployment, right? I mentioned deployment. So running the application in some other server is our set of servers. So why we should be deploying your application in multiple servers? Why not only in one server? Any idea? Any idea anyway?
Cloud is the main difference in both with the exactly. We will build the database, all the.
No, I'm not talking about cloud. My question is why I should deploy my application. Forget about cloud. My question is why should I deploy my application in multiple servers? Why not only in one server?
If you have the server, and if it is a backup purpose, we are using the secondary server also.
Yeah, it's not only backup. So if that server goes down, if you're deploying it in one server, then your application goes down.
Yes.
That is the reason. That is one reason. If it is running in multiple servers, if this goes down, other servers are active,
Yes.
it will be available. Not even switch it, that will be available. Okay, that is one. And the second one is it's based on user base. User base meaning, let's say one server can serve only 250 requests. Okay, and I am getting 1000 requests per second. One server cannot accommodate all the requests. So if you are deploying it in 4 servers, then it can share equally. Then it can serve it so that the response will be quick. Correct? So that is also another reason. So we deploy your applications or services in multiple servers, not only in one server. Now, take an example of one e-commerce application. Okay, e-commerce application you have developed. E-commerce application meaning there is a website and you develop it for your organization and you deploy that website in your on-premise servers. On-premise meaning company-owned servers. And let's say one server can serve like 1,000 requests per second and you are expecting like 10,000 requests per second. So that is the reason you deployed this application in 10 servers. Okay, now everything is working as expected, no issue. Now in December, generally there will be some offers, correct? At that time, you are expecting more number of requests, correct, right? And you are expecting, let's say 20,000 requests, 20,000 requests. Now for 10,000, 10 servers, 20,000, 20 servers, correct? Now you need 10 more servers now. You have only 10. 10 more servers you need it. Now that 10 more servers, you need it only for 1 month. After that, you don't need it.
Yes.
Offers get over, so then you don't need it. Then you need some physical space also. Let's say this much room you are using it for 10 servers. The same kind of room you need it for another 10 servers also, and only for 1 month. Then you need to run those servers 24/7 with security. Fine. And you need also some manpower, correct, to maintain that. Only for 1 month it is difficult to get manpower. Okay, some resources, right? So employee I'm talking about. So even though you are getting it, you need to pay more. That is also a concern. Fine. Now, how do you resolve it? One solution could be you can hire the servers. If you are hiring the servers, you will not be knowing like whether those are in proper shape or not, meaning whether you can use it or not. I mean, some might work, some might not work, all that issues might be there. Okay, so that is one issue. And but other like physical spaces, manpower, running 24/7, all that still exists. So that's the reason what you can do is you can go to cloud platform. Okay, and there is one more issue I'll mention, very important issue, which is how do you predict the number of requests? I'm saying 20,000, but it might be more or it might be less. If it is more, then you need few more servers, more servers. If it is less, not required. Unnecessarily, you are provisioning the more servers. Correct, right? So ideal number of count you will not be having it if you are having it in on-premise servers. Okay, so that is another issue. That's the reason people uses cloud. Okay, cloud is like on-demand basis. Okay, you get the services. Okay, so on-demand basis, it's like pay as you use. Pay as you use. Okay, so meaning I'm using it for only 1 month. Only for that 1 month, you get the services. You get the servers and everything only for 1 month, and you don't maintain those servers. You don't need any manpower. You don't need any physical space. Someone else is maintaining those servers. Correct?
Yes.
Yeah. So that's the reason we actually go to the cloud. But I mentioned one more issue, right? Like, how do you know the number of requests?
Yes.
Correct. So if you are not using cloud, then you know the issue. But in the cloud, the benefit is if I am getting like 20 servers, sorry, 20,000 requests, I can have 20 server only. There is a concept called auto scaling, scale out and scale in. You can increase the number of servers count based on the requests actually. Okay, if you are getting 20,000, 20 servers, 30,000, 30 servers, 15,000, 15 servers. So, correct? So what is the benefit now?
Cost cutting.
Exactly. Cost, right? So
Manpower also.
yeah. So if you are using more, pay more. If you are using less, pay less. Correct? And after the duration you have used, you do not need to worry about those servers. If you are using in like on-premise, selling those servers also is a headache.
Yes.
Correct, right? You don't get even 50% also nowadays. Correct? So it's like, I'll just give you one example. Ola or Uber cabs, any cabs for that matter. So only for the duration which you are using, for that only you pay. Let's say if I'm using my cab, like the cab for 1.5 hours, for that duration I'll pay it. And I don't own that vehicle. I don't need to maintain that vehicle. Okay. So after 1.5 hours, I can ignore about it. Correct. So that's the same comparison we can have it here also. Okay. So that's the reason most of the cases people are using cloud platform to deploy their applications. Okay. Fine. Now there are n number of cloud platforms like AWS, Azure, CenturyLink, Bluemix, GCP, n number. Okay. But we are learning AWS, Amazon Web Services. Okay, why AWS? Why not any other cloud platforms? The reason is AWS is like 70% of the market is occupied by AWS. That's the reason we are learning AWS. Okay, so I am not saying other cloud providers are not getting used. Okay, I am saying the percentage. Correct? Yeah, fine. Now, anyway, once you learn one cloud platform, learning another cloud platform won't be a big challenge, because 90% of the services would be more or less same. Correct? So it's just that the look and feel and how to use will be little different, but more or less same. Anyway, now there are two packages in this. One is DevOps with partial AWS, and second one is DevOps with AWS. Fine. DevOps tools would be common in both the packages, only AWS differs. So in the partial AWS, I cover 6 AWS services: EC2, S3, auto scaling, load balancing, VPC, and IAM. What are all these? These are all the services. Anything in cloud is a service. Whether you are trying to have a server or a security or a network, anything is a service. Now, these are all the services you will be learning as part of partial AWS. EC2 is like virtual machines. Then S3 is for storage, unlimited storage, auto scaling, load balancing, for the concept which I just mentioned, scale out and scaling. Then the VPC is to have your own network in cloud. Okay, private network in public cloud. Fine. So IAM is to secure your AWS services. Fine. So these are all the services you will learn as part of partial AWS. In the full AWS, you will be learning all the services which comes under solution architect certification. Solution architect certification. So I'll quickly open the services which you will be learning as part of solution architect certification. So these are all the ones. Okay, the ones which are in red will be covered extra in the full AWS, like Route 53, databases like RDS. Okay, so then Cloud Formation, Elastic Beanstalk, SNS, SQS, SCS, API Gateway, Lambda, okay, Cognito, CloudWatch, fine, ECS, ECR, storage, all these would be covered as part of full AWS. Okay, and if anyone is interested on solution architect certification, for them I'll be taking little extra classes also. Okay, in detail I'll be covering in that. Fine, like disaster recovery and few more migration steps and all, I'll be covering over there. Fine, fine. Since the reason why I'm not including in this one is people get bored. So that's the only reason. No charge for that. Okay, anyone can, if they are really interested on solution architect certification, they can attend that. Okay. So yeah, so that's about the full AWS. Right. Now let us come back to the DevOps tools. So we learned something like Docker. Using Docker engine, you can create containers. So using container, you can develop, deploy, and ship your applications. Develop, deploy, and ship your applications. Okay. Then there is a difference between Docker containers and your virtual machines, which are all EC2 instances. Okay. What is the difference is, if you are using virtual machines, each virtual machine requires an extra operating system. Guest OS is, it requires extra operating system. Yeah. Okay. But whereas when you are using Docker containers, you do not need an extra operating system. It will be using your existing system host OS. Okay. It will be sharing your host operating system. So that is the reason Docker containers are extensively used for microservices. Okay, so I'll definitely explain microservices architecture, all that in the classes. So Docker is extensively used for microservices, and there are other scenarios as well. So we will be learning Docker extensively. So in the Docker, we learn like how to create Docker containers, how to create images manually and automation, Docker networking, Docker Compose, Docker volumes, all that you will be learning as part of Docker. Then after that, you learn something like Kubernetes. Kubernetes. What is Kubernetes? Kubernetes is a container orchestration mechanism. So to manage your containers in a cluster, we actually need Kubernetes. So what does it mean? So if you are hosting your containers in a single server, then if that container goes down, then your application goes down. So that is the reason what do? We will try to have it in multiple servers in a cluster actually. Okay. So to have that mechanism, meaning to distribute your containers or to manage your containers in a cluster, we need Kubernetes. Okay. So very important. So definitely we will be learning Kubernetes practically. So I'll be taking like a 2 week session, more than 2 weeks also, only for the Kubernetes. Okay, that is very important. Container orchestration mechanism. After that, we learned something called Ansible. Ansible. What is Ansible? So let's say I wish to configure one server. So meaning I wish to install one software, update one software, create some users, then copy the files to that system. If it is one system, manually you can connect to that system and you can make it happen. Not a problem. If the same process, I wish to do it in 50 servers. What do? It takes time. Okay. And also you make some mistakes. And troubleshooting that also takes time. So that's the reason what exactly we do is we use this configuration management tool. Here we write playbooks. Okay, so that playbooks using YML5 under, okay, we learned that anyway. So this we call it as infrastructure as a code. Infrastructure as a code. Okay, so that files can be stored even in the Git and all that can happen. So using that particular configurations, Ansible will connect to each and every server and it will configure it for you. Okay, so that is very important tool. So we will be learning Ansible here. And after that, you learn something called Terraform. Terraform. So why do you need this Terraform? This is for provisioning the servers. Configuration is different, provisioning is different. Okay, provisioning meaning creating the services. Let's say in AWS, I wish to create EC2 instances. I wish to create S3 bucket. Correct? I wish to create VPC. How do you provision that? Okay, manually you can do it. But let's say every day morning 10 o'clock, I wish to have my infrastructure ready. And again in the evening 6 o'clock, it should get destroyed automatically. So how do I do it? Okay, manually, you don't go to every day and do that, right? So that's a repetitive task. So you should automate that. To do that, we can use Terraform. But there is a service called CloudFormation also within AWS. You can use that as well. But the difference between Terraform and CloudFormation is Terraform can be used for other cloud platforms also. Not only to AWS, it can be used for Azure and GCP anywhere. Okay, so it's for enterprise. So that's the reason we learn Terraform as well. Okay, fine. Now, these are all the tools we will be learning as part of this course. So I repeat, in the DevOps, Git, Linux, and shell scripting, Java, Node.js build and release part. So here I'm mentioning Node.js also. Generally outside you learn Java only, but DevOps is not tied to any one particular technology. So if you are interested, you can even work on some real-time projects of .NET in my institute, because it's not only a small institute here. We also have own a company called Ashran Technologies. Okay, so here we work on projects actually. So you can work on real-time projects also in .NET, so that you can cover 3 of them. Fine. So then you learn Maven, then SonarQube, Tomcat, Jenkins, Docker, Kubernetes, Ansible, and Terraform. Then AWS I already mentioned. In the partial, these 6 services. In full, all the services which comes under solution architect certification. So as I mentioned, 2 packages, DevOps with partial AWS, and second one is DevOps with AWS. Both are 3.5 months course duration. 3.5 months. Okay. DevOps with partial AWS is 1 hour per day. Only few 1 or 2 weeks actually it will be 2 hours per day. And DevOps with full AWS is actually 2 months 2 hours per day. Remaining 1.5 month 1 hour per day. Generally classes will be like 8 to 10 in the morning, 8 a.m. to 10 a.m. Okay. So then definitely all the services and the tools I'll be teaching practically by using real-time scenarios. Real-time scenarios and the projects. Okay, fine. Now, I focus on not only getting a job, I focus on sustaining a job. That is most important. Correct, right? So that is the reason. Practical knowledge, you will get it over here. If someone is actually attending offline, that would be more useful than online. I'm not saying online is bad. In the online, what will happen? I can't understand. I mean, I'll not be knowing because I'll not be seeing you. So, yeah, exactly. Yes. Yeah. So,
Understanding the things it is where
yeah,
better understanding how it can change the thing.
exactly.
More examples it can.
Exactly. Yeah. Yeah. So, and even offline, online, like I take all the questions. That is different. But if you are attending offline, what will happen? I can interact, and I'll be based on your face feelings. I'll get to know whether you are really getting it or not. Okay. So that will be there always. And also, as I mentioned, you will get to work on real-time projects if you come over here. Okay. You can attend online all the sessions. Later on in the end, you can come here and work on .NET projects also. Okay. That would definitely help. And I take n number of mock interviews. Okay, whenever you need an interview, just come to me, I'll take it. That would definitely help. The reason is you'll get to know how the format would be in the interviews. Okay, accordingly, you can prepare from the beginning. Okay, so that is very, very important. Okay, so we'll do that. Right. So ultimately, as I mentioned, so you should always think about once I get a job, how do I sustain? If that is there, that is your focus, I don't see any problem. So we will try to achieve that. That won't be a problem at all. Okay. So that's about it. And the daily recordings I'll be sharing definitely. Okay. And it's better on daily basis you practice those things. Okay. The topics. Okay. So that's about it. And now before I get into the pricing, I'll just stop the recording.